In August of 1962 at Bolt, Berneck and Neumann, Joseph Karl Robner Licklider, aka JCR or Lick, formulated the earliest ideas of a global computer network in a series of memos he called the Intergalactic Computer Network concept. The internet at the time wasn't commercially available and didn't get that way until Congress gave it the green light in 1991, which led to the dot-com boom of the mid-90s and the burst that followed in 2001. This had the effect of multiple businesses going bankrupt with multiple billion-dollar data centers that would be made obsolete in short order. These traditional data centers required big upfront investments, hardware that often sat idle, frequent upgrades, and constant IT maintenance that made scaling up or down slow and expensive. As businesses recovered from the dot-com crash, they began to demand easier to use and more reliable hosting. Amazon answered this call by quietly launching Amazon Web Services in 2002. This move would not only reshape the dedicated hosting industry, but the world itself. Now, the origin of the term cloud computing, or what we call the cloud, has been debated. It was either first written on a compact internal document in 1996 or on an academic paper written by 𝗕𝗲𝗵𝗶 on the economics of computing in 1997. We do know the first well-known usage of the term came from former Google CEO Eric Schmidt at a search engine strategies conference held on August 9, 2006. The cloud or cloud computing has multiple definitions depending on who you ask. It is defined by the International Organization for Standardizations as the paradigm for enabling network access to a scalable and elastic pool of shareable physical or virtual resources with self-service provisioning and administration on demand. The National Institute of Standards and Technologies defines it as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. The NIST's cloud model is also composed of 5 essential characteristics, 3 service models, and 4 deployment models. The essential characteristics include on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Being the longest-lived cloud provider with the most services has helped Amazon take and keep the #1 spot since its inception. Microsoft Azure and Google Cloud Platform round at the top 3 with 20 and 12% of the global cloud market share respectively. The other 37% are rounded out by more specialty cloud providers like IBM, Oracle, and Salesforce. These cloud providers have data centers all around the globe, and the big 3 providers share similar terminology to describe these locations. All 3 refer to a specific geographical area that contains one or more data centers as a region. These regions are further broken down into multiple availability zones, which are isolated locations within a region that provide increased redundancy and availability for cloud resources. Going further down, we have edge locations. They are smaller sites strategically distributed across the globe to cache data and deliver content closer to users. All the cloud providers offer similar services, and you can generally group them as core infrastructure like computing, storage, and networking, developer tools like serverless functions, app deployment, and infrastructure as code services, business apps like email, meeting, and video, and advanced services like machine learning, Internet of Things, and data analytics. These services are also formally arranged by what service model they belong to. These models define how much of the technology stack is managed by the cloud provider versus the customer, offering varying levels of control, flexibility, and convenience. From the most to least responsibility on the user end, we have infrastructure as a service, platform as a service, and software as a service. While cloud service models specify how much you or the provider control and manage in the technology stack, shared responsibility, a security and management framework, details exactly which aspects each party is accountable for. The cloud offers major benefits, but there are also important considerations to take before a full adoption or migration. Data residency and compliance laws may require certain data to stay within specific regions or countries. Without good management, cloud costs can soar. If you have no internet connection, you have no access to cloud resources. And the biggest of them is a lack of knowledge, which can lead you into a world of both financial and technical debt. To avoid these pitfalls, I would read up on my local laws around data compliance, carefully monitor your usage and set budget alarms, buy a mobile hotspot, and you need to understand your role. The underlying technologies and the trade-offs between upfront costs versus your time are essential for building the right stack for your application or platform. If you enjoyed this video, a like and subscribe would mean the world. Until next time, good luck and happy coding.
I should be like you, Mel.